We have already discussed about these systems, number systems. The basic one was natural numbers, whole numbers, integers, rational numbers, and after that there were irrationals and all together real numbers. I am just repeating to recall or recollect. Natural numbers were 1, 2, 3 and so on. They are infinite in number, so this set is infinite. Similarly, you have seen integers. We just include 0, 1, 2, 3 and so on. This was whole numbers. Then integers, which is represented or denoted by I or Z. This is a set which includes all the whole numbers and negative whole numbers as well. So we write the 0 in the middle, then 1, 2, 3 and so on, and then -1, -2, -3 and so on. So this was the integers. This is open on both the sides. After 3, 4, 5, similarly more numbers, and similarly -3, -4 and so on. So open both the sides. Q is the rational numbers. Rational numbers included all integers and fractions. All integers and fractions. You have seen that even if you have them in the decimal form, you say either terminating decimal, or if it is non-terminating, then it has to be recurring. So in the form of or, you can say terminating decimals, terminating decimals, or non-terminating but recurring decimals. These are rational numbers. Then if you include some irrational numbers, which included like √2, √3, √5, √6 and so on. Even some numbers which are not surds. This is pi, which is not a surd, but still this is irrational. That much we have already established in the previous classes. Now today we will move further. I hope you can recall, we had said in the introduction that there was some need realized that the set of natural numbers is not sufficient. So we needed to extend that set. We invented few more numbers and then we got this. Similarly, integers also. How was that? That if a person who knew only the natural numbers, or if you recall those days when people knew only the natural numbers, it was not possible to subtract a number from any other number. What does it mean? Like it was possible there that 3 minus 2 was possible 1, but if you ask 1 minus 3 or say 2 minus 3 there, if you ask such question to a person who knows only the natural numbers, 2 minus 3, one will say, how is that possible? How you can subtract a greater number from the smaller? So then we needed that this set was not sufficient. We had included more numbers which were the negative numbers, and then we extended the set and then it became possible. We said now it will become same. This 2 minus 3 will also become 1 as it was 3 minus 2, and we had introduced a minus sign which indicated that the greater number has been subtracted, and therefore including these negatives like -1, and similarly we can get -2, -3 and so on. When you include those numbers, then this set was extended to this. So similarly we get situation, then division was not possible, so we have you can say extended the set using the fractions, and then including the fractions and integers, it became rational numbers. Then it was realized that some numbers are not rational, so they were irrationals, we included them, and then that set was called the real numbers. So what does it mean, real numbers? Which the students of classes I think up to 10 know are all the real numbers, which means that all the natural numbers, whole numbers, integer, fractions, you mean the rational numbers and irrationals all together, all rational, all rational and irrational numbers. A set which contains all the numbers which are rational or irrational taken together, they are the numbers which are called the real numbers, and that set is called the set of real numbers. This is the level, this is that much which our students of class 10 I think know that much. Now today we will go further. Is this set sufficient to work all the solutions, or we come across some situations where this is realized that this set should also be extended further, like we extended natural numbers to get the whole numbers, and that was extended to integers, and then including fractions you got the rational numbers, then including irrationals we got the real numbers. After that I discuss, or I tell you a situation that where we realize that this set of the real numbers is also not sufficient for our work. You know, when you come across solving certain equations, you know, you solve x minus 2 is equal to 0, you get a solution x is equal to 2. Suppose you get a solution, an equation 2x minus 1 is equal to say 1, you get x is equal to 1 upon 2, etc. You solve such equations. Even if you say solve this, you solve this, or you solve this, x square is equal to 3. What are the values of x? We say when x square is equal to 3, you get x as root of 3, positive or negative it is possible, because you know that the square of positive number is also positive, the square of a negative number is also positive. So therefore, when you obtain the value of x, here you can say square root of 3 will be this number. So x square 3 will mean x is positive root 3 or negative root 3. This much we have seen. Now we are talking about a situation. What happens when you say solve x square plus 1 equal to 0? What do you get? You get a situation that x square is equal to minus 1. What are the possible values? You have to think that what number put here in place of x squared should become minus 1. And you know, 1, if you put x equal to 1, 1 square is 1, not minus 1. So 1 is not the solution. If you take x as minus 1, you put minus 1 in square, minus 1 square is also plus 1. So you do not get minus 1. So there is no value which when written in place of x and squared, you get minus 1. So if you know up to the real numbers only, you will say no solution, which means not possible. Like for a person who knew only the natural numbers, 2 minus 3 was not possible. That set was extended further to see that what will be the possibility, how we can express that. So similarly, when you came across in the situation that x square is equal to minus 3, minus 1 or any negative number, what will be the value of x? We find that this is a constraint. We have all the square numbers as positives. So therefore, in order to solve these equations, we needed to extend our set of real numbers. And how it was done? Like there in the set of natural numbers to integers, when we came, we had invented a negative sign. Here also we need some invention. What is that invention? We say x is equal to root of minus 1, square root of minus 1, which could be positive or negative, of course. But for this root of minus 1, we will give a notation for that. We take a symbol. In fact, this work was done, I think, in Greece. So therefore, the standard symbol which was taken there was iota. So root of minus 1 was denoted by iota, which is a symbol, that alphabet, somewhat like this. We call it iota. Root of minus 1 is denoted by iota. Since in our script, when we write in the in this English books, it resembles I. So therefore, we have adopted almost that this root of minus 1 also written as I. So we say root of minus 1 will be denoted by I for further now. Iota actually, or I also denotes that. Root of minus 1 is I. This makes it possible now to solve the equations of this kind. Like if you have to say x square plus say 9 equal to 0. Solve it. So you will say x square plus 9 is equal to 0 will mean x square is equal to negative 9. So x square will come to be root of negative 9, which could be positive or negative, of course. And what about the value of this root of minus 9? we will say this can be written as 9 multiplied by minus 1 or negative 1. And therefore, this is written, let me write it here. So, this is denoted written as plus or minus. Root of 9 could be written as 3 and root of minus 1, and we have said root of minus 1 will be denoted by iota or I. So, therefore, the answer will come to be plus minus 3 iota or 3I. So, this makes it possible now that you can solve x square plus 9 is equal to 0, you get x square is equal to minus 9 or x square is equal to, this should be x as positive root of negative 9, positive and negative. And therefore, you can convert right in this form, and therefore, when you take square root of 9, it is 3 outside, or root of minus 1, negative 1, which is denoted by I. So, this is how we start the work on the set of numbers which are beyond reals. But let me tell you that these numbers are called the numbers, since the previous numbers were called the real numbers. Therefore, when it was found that we have to give a name to this new type of numbers, the name was given to be imaginary numbers. So, earlier we had real numbers, the name is given imaginary numbers, but let me make it clear that it is not that these numbers do not exist or they are not the actual numbers, they are only imagined. Not true. That, like you can see, beyond the natural numbers was whole numbers, and beyond that was integers. Similarly, beyond the real numbers are imaginary numbers. Not that they are simply imagined and they do not exist. The fact is they do exist very much as any other numbers or real numbers exist. So, simply these are the imaginary numbers. Okay. So, root of I said minus 1 or root of minus 3 or root of minus 9, etc. can be expressed now. After that, I will come to the representation of imaginary numbers. Representation of imaginary numbers. But before that, I think we should discuss a little more that if you have I as a root of minus 1, what will be the value of I square? It will square both the sides, root of minus 1, and this root is removed, and we will get this. So, I square is equal to minus 1 or negative 1 will be the fact. If you have to obtain the value of I raised to power 7, what will be its value? We can say this I to power 7 could be written as I to power 6 multiplied by I or iota. Then, as we know the fact that I square is negative 1, we will convert this I to power 6 as I square cube and I. Why we are doing that? Because we know that I square is minus 1, we want to make use of that. So, I square is minus 1 cube and multiplied by I. So, therefore, minus 1 cube is minus 1. You get minus 1 into I or minus I. So, negative I will be the simplified value, right. So, similarly, if you have any other number, any other numbers of this kind, so we should be able to simplify them. So, I will come to this, but let us take one more example. If you have to simplify what is the value of say I to power say 99. First of all, we will see that we need to convert using that I square, because I square is equal to minus 1. This is the fact we know. So, therefore, what shall we do? We will write as I to power 99, which is an odd number power. So, that is to be converted into the even number power. 99 can be written as 98, then multiplied by I, because I will mean this. I raised to power 99 could be written as I raised to power 98 multiplied by I, and I to power 98 can be written as I square raised to power I, this is not a decimal, I square raised to power 49, and then I as it was. 2 into 49 is 98, am I right? Yes. So, I square is minus 1 raised to power 49 into I, and then I square this minus 1 raised to power 49, which is an odd number power, minus 1 raised to power 49 is minus 1 into I, or simply minus I. This is how you can simplify few more these quantities in the form using I. We will take more examples in the form of exercises, but I want to discuss here the concept of representation, and then of course we can take the questions from your exercises also. You know, like we represent all the real numbers on the real number line, 1, 2, 3, and so there we can understand and distinguish that 1 has a certain place, 2 has another place, 1.2 has a fixed place. So similarly, different imaginary numbers can also be represented in the form, not of course on the number line, but there is another method. So what is that method? So I tell you that when you are talking about the imaginary numbers or the complex numbers, what are the complex numbers? Complex numbers means that a part of that may be real and another part may be imaginary. Like say 2 plus 3i, or maybe 1 minus I. What does it mean? You can write 1 minus I as I into 1. You can say 3 plus 4i, etc. Where this part is real, this part is imaginary. So we say, let us denote it by z. About the sets, z denotes the set of integers. About a number, z denotes complex number in general. So then we write real part of z, Rez is equal to, the real part of z is 2. So Rez is 2, real part of z is 2, and imaginary part is 3i, but here it is customary to write imaginary means Im of that z is 3. So we will write here 3, which will mean that 3i, only the coefficient is written here. So imaginary part is actually 3i, but we write here coefficient only. Okay? And then I come to one more fact. So this can be written in the form 2 plus 3i, which can be written as 3, 4 also in the form of coordinates. I will come that how we will be writing them. So what happens that if you take a complex number in general, which has a real part and which has another imaginary part as well, so z is equal to x plus iy I am taking. And you know, to represent that, we take them in the form of coordinates x, y. What does it mean? Along the x axis you take x units, along the y axis you take y units. This is the origin, this is x axis, which is the real part of that z, and this is the y axis, which represents here the imaginary part of that z. And when you write here x, y, which will mean that you start from the origin, go x units there, and then y unit this side. So you get here that this is the point P, and this means here that this length is x, this length is y, and this length can be taken, of course. So this location, which is x, y in the form of coordinates, represents that complex number x, y. Same way, if it was 2 plus 3i, it will be represented by 2, 3, 2 units here and 3 units here. If it was 3, 4, which will mean 3 plus 4z. Okay. So the representation will be like you can take the real part and the complex part along the x axis and the y axis.